Short answer question 2 asks us to consider the function f of x equals 1 over x squared plus 2x minus 8. It asks us to determine the key features of the function, such as the domain and range, intercepts, and equations of any asymptotes. So the first thing we want to do is look at this function here, f of x, and factor out the bottom of this fraction, because that's going to help us consider it and determine these key features better. So when we factor out the bottom, we want something that multiplies to -8 and adds to +2. So that's going to give us x plus 4 times x minus 2. 4 times -2 is -8, and 4 plus a -2 is a +2. So now we can look at this to determine our domain. So that's part I. So our domain is our restrictions on x. So looking at this, we can see that x can't equal -4 or +2, because that'll make the bottom of this fraction have a 0 in it, and that's undefined. So we say that the domain is x is all real numbers, but x cannot equal -4 or +2. Okay, and so let's look at our range. This is our restrictions on y. And looking at this function, there's only one value that y cannot equal, and that's 0, because if we don't have a 0 on the bottom of the fraction, then this that would make this function undefined. But we can never have a 0 on the top of the fraction because there's a 1 there, and so this function will never equal 0. And so our range is that y is all real numbers, but y cannot equal 0. Okay, so moving on to part 2, we're going to look at the intercepts. Okay, so to do this, if we think about the x-intercept, that's where the function crosses the x-axis and y equals 0. We've just said that y cannot equal 0. So we have no x-intercept. For the y-intercept, that's where x equals 0. That we can find. So we just take our function, f of x, and plug in x equals 0. So if f of x equals 1 over, I'm going to use this form of the function, x squared plus 2x minus 8. And now we want to find what y equals when x is 0. So I'm going to plug in 0 for x. We get a 0 squared plus 2 times 0 minus 8. That's going to simplify to 0 plus 0 minus 8. So we have a -8 at the bottom, and -1/8 is our y-intercept. So y-intercept is -1 over 8. Okay, so part 3 asks for equations of any asymptotes. So for this part, we want to look back at what we found for our domain and range, because that's going to help us figure out the asymptotes. And so since our domain, we said that x can't equal -4 or 2, that means we're going to have vertical asymptotes at x equals -4 and x equals +2, because the function will never quite reach these values. So we can say that we have, for our vertical asymptotes, they are at x equals -4 and x equals +2. Those are those equations. And for a horizontal asymptote, this is going to be at y equals 0 because we've said that our function will never quite reach y equals 0. It's one of the restrictions on our range. But let's one way to prove that this is a horizontal asymptote is to plug in or look at the function when x is approaching infinity. What does f of x approach? And it should be 0 if we have a horizontal asymptote at 0. So let's take our function as x approaches infinity. What does f of x approach? So we have 1 over x squared plus 2x minus 8. X is approaching infinity. This negative 8 becomes inconsequential, and so this will become 1 over x squared plus 2x. And we can see that if x is approaching infinity, the bottom of this fraction is going to get really, really large. So we're going to have 1 over a really, really big number, essentially 1 over infinity. And that is going to be a really, really small number. So that's going to essentially approach 0. So yes, as x approaches infinity, f of x approaches 0. So we have a horizontal asymptote at y equals 0. Okay, so we've answered the questions in part A. Now let's move on to part B. So part B asks us to sketch the graph of the function. So let's put in what we know about this function. We've said that we have vertical asymptotes at x equals -4 and x equals +2. So I'm going to sketch those in as dotted lines. At x equals -4 and +2. Also said we have a horizontal asymptote at y equals 0. So I'm just going to indicate that here. And we've also said that the y-intercept is -1/8. So that's going to be kind of about here. That's where our function crosses the y-axis. Okay, so now we need to figure out what this function looks like. And one other thing that we can put in here, we know that when x is approaching infinity, positive infinity, we showed that f of x is approaching 0. So that's going to be over here. We know that the function kind of looks like this. It's getting really close to 0 as x approaches positive infinity. And we can figure out what it looks like on this side by plugging in a negative infinity for x. We'll see that it also approaches 0 here. And then to figure out what the function looks like when x approaches +2, what we can do is say, all right, so when x is approaching +2 from the right side, that's what that plus indicates. Let's see what happens to y. And so to do that, we just sub in a value very close to 2 from the right side, so that's going to be just a little bit bigger than 2. We'll sub in x equals 2.001. And so our y would then equal 1 over 2.001 plus 4 times 2.001 minus 2. That's going to be 1 over 6.001 times 0.001. And when you evaluate that out, you get when you evaluate that out, you get 166.7. Okay, and so as x is getting even closer to 2, so if you keep adding zeros here, this is going to become bigger and bigger because this number is becoming smaller and smaller. That means the bottom of this fraction gets smaller. 1 over a really small number is going to be a really big number. So we can say that as x approaches 2 from the right, y is going to approach infinity. So this is going to go up like that. And then to figure out what happens on this side, as x approaches 2 from the left, do the same thing. So as x approaches 2 from the left side, sub in something really close, just under 2. So that could be something like x equals 1.999. And what you get if you do that is that y equals negative 166.7. So just the negative form of that. So we can see in the same way, this is going to, as x approaches 2 from the left, y is going to approach negative infinity. So on this side, the function is going to go down like this. Okay, and you can do this on the same side over here. So find out what happens when x approaches negative 4 from the left and from the right. And if you do that, you'll see that y approaches positive infinity on this side and negative infinity on this side. Okay, so now we just need to figure out what happens in this area. And we've said that we have a horizontal asymptote at y equals 0. So this, we're not going to cross the x-axis here. And so this is going to look something like that, right? And you can plug in some points in between here to figure out what the function looks like here. It actually curves quite steeply here. And so you could plug in like y equals negative 1 and figure out what x equals at those points. So if you do that, at y equals negative 1, so when y equals negative 1, x equals positive 1.8 and negative 3.8. So you can see that they're very close to the asymptotes at y equals negative 1. So that's kind of the shape of the function there. Okay, so those are the answers to short answer 2.